Okay, everybody, welcome. This is chapter 6, section 1, lesson 1. This is dealing with something called systems of equations by graphing. Okay, so we're in this chapter, we're going to learn how to find the answer to two separate equations and getting an ordered pair to be able to do that. So we're going to start off with graphing them on a graph. So if you guys go ahead in your notes, write down the system of linear equations, and then that's the definition. And remember too, while you're taking notes, if I start going too fast, just hit pause, get your notes caught up, then go back and hit play again. Okay. So a system of linear equations is two or more linear equations that are related. Okay, so we're going to just deal with two, but get into some higher math, you'll get two or three equations, four equations perhaps, where they kind of maybe hopefully intersect on a graph, or you can create a point. Okay. The solution of the system of equations is any ordered pair. It's a point, so remember that's an x or a y value, and that makes all the equations true. So if you go ahead and write down these two equations, y equals 1/3 x plus 1, and y equals -1x plus 5. Okay, now for us to be able to do this particular section with systems, we have to make sure that our equations are in this form. Okay, I'm going to need a starting point and a slope to be able to do that. Okay, so for this first equation, y equals 1/3 x plus 1, your slope is 1/3, and your b, or your starting point, is +1. Okay, for the second one, your slope is that -1. Remember, there's a 1 right here, and your y-intercept is +5. Okay, so you might want to just get in the habit of writing that down so you can be able to do that. Okay, so. And then if you could draw yourself a graph, and we'll go ahead and we'll sketch the graph for this. Okay. And then if you have a note packet, then this is kind of already done for you. But if you're doing this at home, you don't have a packet, just sketch a graph. I'm going to do the first one here. Okay. So my starting point's at +1. My slope is +1/3. So remember, that's up 1 and then over 3, and then that's where I get my line. Okay. And then I'm going to go ahead and graph the second equation. So that's this one right here. Right? Your starting point's at +5, but your slope is a -1. So that means it's -1/1. So I'm down 1/1. Down 1/1. I kind of keep doing that, and I can draw my line. Okay. So what I'm looking for is if these lines intersect. Okay. So these lines intersect, and the solution is that point. So remember, your point is an x and a y value, and so at that point, my x value is 3, and my y value is 2. Okay. So that's a solution, and what I could do is I could take that point and go plug it back into here and into here, and I should get, one side equals the other. All right. So that's how I do systems with graphing. First off, get it into y equals mx plus b. We were kind of fortunate. It was already given to us that way. We graphed them, hopefully graphed them correctly, and then we're finding out the point that they intersect. Okay. So if you'll sketch 2 more graphs for me, please, for these two that are on the right, and we're kind of write an explanation here. If you'll draw a graph, and then graph the there's 2 lines here on the top one. There's actually 2 lines on the bottom. If you're watching this video, hopefully you see there's one in purple and one in green, but they're sitting on top of each other. Okay. What we're looking for technically, typically, is that the lines do cross, but occasionally we get these different kind of situations. So this first one here, the lines are not crossing. So when lines don't cross, they're called parallel lines. All right, so I want to write that down. And if lines are parallel, what I'm doing is trying to find a solution like I did back here. The solution or the answer is where they cross. If they don't cross, then there's no answer. So when I have parallel lines, there is no solution. Okay? There's no x and y value where they intersect. In the second one, when I have two lines they're technically on top of each other. So I don't know if you have like different color pens or pencils, you could do that for this one. But two lines are really sitting on top of each other. That means that they're intersecting at every point along the way. Okay, so if they've got multiple intersection points, then that means this one has a solution of all real numbers. Okay, so these two are kind of some exceptions to the case of what we did in this first graph. Okay, so no intersection is parallel lines. Parallel lines have no solution, and lines that intersect in multiple points are going to sit on top of each other, so they have infinite, basically, solutions. Okay, so make sure you really look at that and study that, because those are things that show up once in a while. You need to know what the answer will be. Okay. All right, so if you guys go ahead and write down these two equations, and then if you'll sketch a graph also. And they're going to want us to check our answer here too. So we're going to graph it first, get our point. If they do cross, and then we're going to plug it back in. Okay. Now, the first thing I want you to remember too is to be able to graph stuff, it has to be in this form. So that's the first thing we're going to do, is check to see if they both are in that form. So this first one, they're not. Y is not by itself. Okay, so I need to move the x over. So to do that, I'm going to add x to both sides. And I get y equals x plus 2. Okay, so now y is by itself, so I can go graph it. Remember, there's a 1 right here. Okay, I'm going to check the other one just since I'm doing this. I'm going to check this guy, but y is by itself, so I'm good to go. And let's kind of get a habit here. In this one, my m is positive 1 over 1. Okay, and your b is 2. Okay, here my m is 3 over 1, and my b is a negative 2. Don't forget to bring that sign with it. Okay, so now I got both my slopes and my y-intercepts, so my starting points, however you want to call that, I can go ahead and do that. The first one, your b was a positive 2, and my slope is 1 over 1, so up 1 over 1, and kind of keep doing that. I'll go down 1 over 1 the other side, and that's going to be my line. Okay. All right, I'm going to draw that very straight. Sorry. Okay. Second one is negative 2, so I'm going to go ahead and put my point right there, and my slope is 3 over 1, so up 3 and over 1. Okay, and this is why I kind of keep doing it, because I really want to make sure I got a straight line and things match up. Let me do this in a different color too, sorry. So up 3 over 1 again. I'm going to come down the other way and just put one more point, and my line looks like that. Okay, so it looks like to me, and I didn't draw a straight line again, looks like that they should match right there. So that point right there is going to be my x value is 2 and my y value is 4. Okay. Just be careful, draw your line straight. Okay, now what they want me to do is check it. So what I'm going to do is take that x and the y value and go plug it back in here for x and y, and also here. It has to work for both. Okay. So it's minus my x value, which was 4. So don't forget about that. That minus sign has to stay there. And negative 4 plus 2. Oop, I got that mixed up. Timeout. My fault. My x value was 2. My y value was 4. Right? So 2 equals 2. All right. Go plug it back in over here. My y value was 4. My x value is 2. And I get this. And 4 equals 4. So that point is the solution to the system of equations. Okay. All right. Okay. So then this is kind of how we can apply it. All right. One satellite radio service charges $10 per month plus an activation fee of $20. So I'm looking at the cost of my bill. Okay. The activation fee is where my bill starts. So that's like my B. Okay. And it's $10 per month. Okay. So that's the first bill. So hopefully you understood that. My bill that I get in the mail or online to activate my service, it's going to cost me 20 bucks. Someone's going to flip a switch and say, this person's good to go. Then for me to actually use that satellite service, it's going to cost me $10 per month. Okay. The second one, I'm going to have a cost. Okay. And they charge me $5 per month and an activation fee of $40. So my bill on this second one is going to start at $40. You know, someone flips a switch and says, Casnick can use our stuff. But then it's going to cost me $5 per month to be able to use it. All right. So what we're going to do here, the y-axis, if you could go ahead and draw this is just the first quadrant because everything's positive. The cost is going to be up the y-axis, and my bill changes by how many months I'm actually using it. So that's going to be my x-axis. Okay. And my starting points here are my activation fees, and my slopes are the costs that I have per month. Okay, so these are like 10 over 1 and 5 over 1. Okay. So let's go ahead and graph these. We'll do the first one. My starting point is going to be at 20, and then my slope is 10 over 1. And you'll notice that up the y-axis it goes by tens. So 10 over 1 is going to look like this. Okay, up 10 and over 1, and then I can draw a line. And I technically shouldn't be drawing a line because it's 10 bucks per month, but I just want to make sure you see it. These are just, and this one's just points because I can't get any like partial months. All right. And then the second one, your starting point's at 40, but you're just going up 5 over 1. So only going to go up half of a square and over 1. Half of a square and over 1. Half of a square and over 1. Half of a square over 1. Half of a square over 1. Okay? So then I'm going to connect it just so we can see it. And that's what my line should look like. Okay? And then now the question is, in what month was the cost of the service the same? Okay, so the cost of the service is the same where they intersect. They intersect right there. If I look, that's going to be at 4 months. Okay, so their cost is going to be the same at 4 months, and the cost at that particular time is $60. Okay, so that's, you know, when do I ever use this as a point where you would use this? Now, you might not use this because you're doing the service. You might be someone that actually works for a company or something that's looking at things to provide information. Okay. All right, so that's a pretty good one right there. Hopefully you understood how to write these two, anything you're gonna have a starting point. Anything's gonna change, which is always your slope. Okay, so these were your slopes. Right? Okay. Hopefully got that. Those are pretty good ones. Those are test questions, so you might want to put, star this one and come back and look at this and study. Okay. All right, so that takes care of section 1. Make sure that you're putting everything in y equals mx plus b. Make sure you graph it properly, and remember parallel lines have no solution, and then lines that sit on top of each other, they're going to have infinite number of solutions or points where they intersect, so they're all real numbers. Okay. All right, so do your homework. If you got questions, please get a hold of me, and we'll make sure that we can get things figured out and you're going in the forward direction. Okay, take care.